In this demonstration, we'll model a set of dice using Rhino 3D. You can open up the application and use small objects millimeters that can also be set as the default template. A typical approach to 3D modeling is to look at the object and determine the underlying shapes. For the dice, that's easy to see that we're going to be using simple square and circle. Moving into Rhino, we'll check a couple of things to start out. Check that your units are set to millimeters. Your grid fine lines should indicate 1 millimeter, and heavier lines should be placed every 10 units. To check, under the drafting menu, linear dimension, you can click 2 points, take a measurement to make sure that that corresponds. You can also change the grid settings by going into the Rhino menu, change settings or preferences. Your modeling age should be set to grid snap, object snap, and gumball turned on, and the rest of them can be turned off. We'll start by drawing a simple square. Under the curve menu, I'll use the command polyline. Snapping into points, we can draw a perfect square, coming back to the original starting point to close it up. Another way to go about this under the curve menu is to use the rectangle command, corner to corner. Start by laying down a point and moving across to your second point. Both of those are the same closed curve. We'll now start moving this into space. Under the surface menu, I'll use the command extrude curve straight. Follow the prompts and select the curve, press enter, and we can now extrude it up to a set distance. We can move into the right or front views and click in place. You can also type in a value of 20 and press enter. On the perspective view title, we can click on the ghosted option. That changes the view so that we can now see those surfaces in place. This shows 4 surfaces that are joined along the edges, also known as a polysurface. We're now going to close up the top and bottom in order to create a closed solid. This is how things will be understood to be solid objects within the software. Under the surface menu, I'll first use a command called planar curves. Here I'm going to select the original square that was drawn. I'll click along this edge and notice that a menu comes up asking which of these we intend to select. You can click on the curve highlighted in pink. That is now selected. Press enter. We now have another surface in place, and we'll create a final one using the edge curves command. Here I'll take the edges of these vertical surfaces, and we now have the final surface. This is still not understood to be closed. These need to be joined together from the first to the sides to the bottom. This is now considered to be a solid object. There are no openings along the edges. It's a completely enclosed volume and can be fully understood. To create the sphere, we can go about it in a similar way. I could, under the curve menu, use the arc to draw a 180-degree arc that can then be revolved along the center axis to a full circle to create a sphere. We can simplify this by instead moving into the solid menu using the sphere command. Using the center and radius, I can click into place and move across 2 millimeters to create a sphere with a diameter of 4 millimeters. Notice too that the solid can allow you to create a box, which can do the same thing as what we had done previously. Select the sphere and click on the arrow to drag it into the center. We now have one piece in place, and we're going to copy several others out to get all of the holes in the right spot. Under the Transform menu, I'll use the command Copy, select the object and press Enter, and then we can select a point away from the object to then copy other objects into place. Make sure that you're getting it positioned evenly with 2 millimeters from the edge of the box to the sphere. We can use other transform commands, such as mirror. Following the prompts, I'll select the two objects, press enter, and now I'll draw a plane along the center, one point and a second point straight down to complete. A standard die has opposing sides that add up to 7. So in this case, opposite 5 will be the number 2. Here I can select one of the spheres and then hold down Shift to add to the selection. This is a simple copy. I'll lay down a point away from the object, straight up into place. I can copy more of them, but I can also just press Enter. I'll add the center to the selection, and this time I'm going to rotate using this icon. I'll click into this corner using the bottom plane as the first reference point and moving it up. Before I click, I'm also going to turn on the copy option so that we can end up with copies in place. And then I can press enter. We can change the selection. I'll hold down Command and then add to the selection with Shift and then repeat the rotate. Copy that out to the other side. Finally, we'll put the 6 and the 1 in place. This seems to be easiest just using the rotate command from this center, like that, and then drawing a box around and copying that out once more. Here I'll use the icon and copy it along the side. You can move around the object just to make sure that things are moving into the right place. We also now just need a single piece. The 1 can be created in several different ways. Here I'll just select the middle of the 5, copy to create another 1, but then move it up into place into the center by looking at it from some of the different views. We now have everything that we need in place. I can come in a little bit closer by double-clicking on the viewport title. We can rotate using the mouse or the trackpad. Double-check that these are where you want them. The next step is for us to start cutting these away from the cube. Where you have overlapping solid objects, you can then use a set of commands called the Booleans. This will allow you to do some simple cutting or unioning in different ways. Under the solid menu, you can find these commands here at the bottom. There's Boolean Union, Difference, and several others. The one we're going to use here is Difference. We'll follow the prompts. These are important to get them in the right order. And we can see it has delete input. The polysurface to subtract from is going to be the cube. Press enter. And the surface to subtract with is going to be some of these spheres. Once you press enter, you can see that it combines those surfaces, removing the second set, but cutting it away. We can run that same command and complete all of the pieces at the same time. We can find this in the icons using the Boolean difference, selecting the object to cut from, and then all of the objects to cut with. Press enter. Here we have the result. Finally, we're going to round out the edges. For this, we're going to be using, in the solid menu, a command called Fillet Edge. This is really important that we do all of these at the same time. The radius that we're going to fillet, we'll start with 2. We're going to first select all of the straight edges and see what kind of result we get with that. It's always better to do these all at the same time, otherwise it can break some of your geometry. Now you can see that the fillet radius of 2 is a little bit too much, and it's coming too close to the cutouts. I'll undo Command Z and restart that command, Fillet Edge, and we'll reduce that to 1. Selecting all of the straight edges so that it can sort out the corners easily. We can also round out the edge around all of the spheres, but those need to be a little bit less. Repeat that command, Fillet Edge. Here we'll move down to 0.5 and then select the remaining edges. We can also draw a box to select them all. We can see the result. It's important to make sure that your edges are clean and don't interfere or overlap with each other. I'll have a look at this in the monochrome view so we can get a better look. It can be helpful to repeat the process to create your second die. If you're confident with how things have gone, you can also select the object and copy it out to create the set. Thanks for watching.